Okay, good afternoon. Assuming that you're in the same time zone as me, thank you for attending session 2 of the Satellite and the 5G Journey virtual conference. And we can go straight into the presentations. Now I'm going to start with, bear with me, with Banu Devasala, who is Vice President International Products and Operations at Hughes. Banu has spent pretty much all of his career with Hughes, a period spanning 3 decades, where he, as I say, currently serves as Vice President of International Products and Operations. So let me get straight into this. Bear with me.
Hello, my name is Banu Devasala, and I'm with Hughes Network Systems. My presentation is on satellite backhaul and the role it will play in 5G ecosystem. One of the key performance indicators of 5G is ubiquitous access, including in low-density areas. Today, terrestrial networks cover only about 25% of the world's landmass. There are around 3.7 billion people, or nearly 50% of the world population, without internet connection. Clearly, satellite-based connectivity is the answer to reach people in these areas where terrestrial networks cannot reach or it's not economically feasible. Satellite technology has itself evolved with high-throughput satellites, with low Earth orbit constellations to address latency, with operation in multiple bands, including Q and V bands for higher data rates. And more importantly, the cost per gigabit has significantly come down to make it very attractive for network operators to expand their coverage with satellite-based connectivity. 5G is truly a network of networks, and under that umbrella, there are multiple roles for satellite. Satellite will have a part in all the 5G applications and service categories. For enhanced mobile broadband, the most obvious one is increasing the geographic footprint to provide broadband services to the unserved and the underserved areas. At these remote locations, satellite will provide broadband access, with over hundreds of megabits per second. Satellites will also provide broadband connectivity for airplanes, ships, and other on-the-move applications. Now, for ultra-reliable and low-latency communications, while the physics of the delay over satellite link cannot be changed, satellites can offload traffic from terrestrial networks during busy hours and provide network resiliency by acting as backup connectivity path in case of terrestrial network failures. For massive machine type communications, with applications for Internet of Things rapidly growing, satellites will play a big part in connecting billions and possibly trillions of IoT devices to application servers in core networks. Next, let me walk through major applications for satellite in urban and rural areas, as well as mobility. Well, satellite is thought of primarily for rural areas where there is no terrestrial connectivity, or if there is, it is very poor. That view is changing fast to support satellite use in urban areas where there is ever-growing demand for video and high data consumption, that is literally congesting terrestrial backbones, especially during busy hours. With the combination of intelligent path selection and routing with SD-WAN and advent of high throughput satellites, the landscape will be moving towards using the satellites to offload terrestrial network traffic. Delay-sensitive traffic such as voice, streaming video, gaming, and so on will continue to use a terrestrial network, while latency-tolerant traffic such as web browsing, software upgrades, email, and other background traffic can be routed over satellite connection. Satellite is also excellent for broadcast and multicast traffic used for video broadcast, regional alerts, and so on. In addition, satellite with its overlay coverage for multiple terrestrial network segments is a natural fit for quickly restoring network services to end users when there is a failure that is associated with the primary terrestrial network path. Finally, there are many IoT applications in urban areas that do not have low latency requirements that are better served with satellite than competing for terrestrial resources. These include things like smart parking, public transport, utilities, and many others. In rural areas, clearly the big ticket item is bringing broadband service to the many who currently have no internet access, or if they do, it's low quality. The main challenges in these areas is affordability. Today, multiple satellite service providers are deploying services like community Wi-Fi, where users can buy data packs on an hourly, daily, or weekly basis as and when they desire. The business model works since you have many such users at a given hotspot. 5G base stations at these rural sites will be able to expand Wi-Fi-like broadband coverage from around 150 meters to a few kilometers, and provide more geographic access along with more hours of service availability for folks in these places. With the goal of bridging the quality of experience gap between users in rural areas and those in urban areas, a key ingredient to achieving this is content caching at the remote site. This will make user experience significantly better, where the user is able to access content such as videos locally without incurring noticeable delays, as would be the case if the access was over the satellite.
Caching at the remote site.
In satellite, of course,
this will make user experience significantly better, where the user is able to access
but also will be
such as video locally without incurring noticeable delays, as would be the case
when a remote can be serviced by both geo and non-geo satellites, the user quality of experience can be further enhanced by intelligent routing of traffic. For example, delay-sensitive traffic would be routed over LEO satellites, and delay-tolerant traffic can be routed over geo satellite. IoT applications are another key area that satellite can enable with connectivity from sensors and aggregation points in the remote locations to application servers in the central or core network. The IoT applications include precision farming for automated seeding, precise watering and fertilization, soil testing, and so on to significantly improve yields while cutting down costs for farmers. Other applications include healthcare, disaster and risk management, and many more. Mobile edge computing in 5G with satellite backhaul also bridges the gap between services offered in rural and urban areas. Take healthcare, for example. The combination of IoT medical devices and applications for edge computing will enable high-quality medical care. Medical database access and internet connectivity will no longer become a hurdle. There are many such use cases for mobile edge computing. So we covered urban and rural areas, and one other major satellite application in 5G is for mobility. Satellite can bring broadband connectivity to airplanes, vessels, trains, and vehicles with support of both multicast as well as unicast on-demand content. With new flexible and dynamic resource allocation technology, satellites will be able to efficiently provide bandwidth where and when it is needed. This makes them very attractive for communications on the move. Another important role for mobility is that the satellite overlay network can fill in terrestrial coverage gaps for comms on the move. For example, as a train travels between towns, connections will be transferred from terrestrial to satellite as the train moves away from the town, and connections will be handed back to the terrestrial network as the train approaches the next town. In summary, satellite will indeed play a major role in the 5G system. There are some key drivers for integration of the satellite and terrestrial networks in this ecosystem. They include providing a similar quality of experience for users, regardless of their location, with technologies like content caching, mobile edge computing, intelligent routing based on traffic type, and others. Use of automated orchestration for services and applications across the terrestrial and satellite networks is going to be essential to quickly enable services with appropriate QoS wherever and whenever they're needed, and with network security. This will be possible and cost optimized with software-defined networks along with network functions virtualization. In addition, NFV will provide flexibility to scale the network and significantly improve deployment time. Another important objective will be to reduce power consumption of user devices as well as IoT devices that are in idle mode, especially those served by satellite backhaul in remote areas. Further spectral efficiencies can be achieved with dynamic frequency sharing between the satellite and terrestrial network segments. Finally, the 3GPP standards should continue to evolve to support the convergence, like the inclusion of non-terrestrial network new radio, which is planned for 3GPP release 17. Well, that's the end of my presentation. Thank you very much for your time.
Okay, thank you, Banu. Right, thanks for joining us, David. I know it's quite challenging, these new, these new platforms, but I'm going to put your presentation up now. If you could just bear with me one moment. Okay, and just a quick introduction, because there are just so many out-of-industry people that are listening in on this. It's necessary to, just to make introductions for our speakers. David has spent 6 years in Intelsat in corporate restructuring and regulatory roles before moving to TerreStar Networks for 5 years, and then to the humanitarian sector, spending close to 13 years with the American Red Cross, finishing as General Counsel and Chief International Officer. He currently serves as Secretary General of the GVF, a global trade association for the satellite communications industry. David, you can hover, I'll unmute you. You can hover your mouse over and click on these little V's here, these little arrows, to move your slides forward. David, can you talk? David, I don't seem to be able to unmute you. So what I'm going to do, I'm going to move forward with another presentation and we'll take it from there. I think you might have a connectivity issue. Just bear with me 1 second. Let me, Richard, are you there? Okay, no problem. Let's bring Luke's presentation up and we'll move forward with that. Oh, Richard's here. Okay, good. Bear with me. Okay, Richard, carry on, please.
Thank you. Can you hear me?
I can hear you very well, thank you.
All right. So let me figure out the controls of this service and go to the next slide. So what I will start out talking to you about today is 5G and satellite backhaul in specific. And as we've discussed already today and in the previous session, as well as Hughes so eloquently explained, the use cases of 5G is expanding way outside the traditional use cases of telecom, that is simple telephony and mobile broadband. And the satellite industry is actively engaged in 3GPP more than ever. And 3GPP has as a clear goal as of release 16 and onwards that the scope of the use cases and technology shall increase. So hopefully this will not end up just being another G, but being truly transformative and disruptive for many industries going forward. So to look at where we start with 5G and put it a little bit in relation to LTE, it's important to understand the history a little bit. And if we look at the left-hand side here, in the spider chart, the light green circle, IMT Advanced, this was the goal that ITU put out for 4G in 2008. And if you look at the upper left-hand side there of the spider chart, you see, for instance, that the peak data rates that were envisioned was 1 gigabit per second of the technology. And this eventually happened, and as Alison was talking about earlier, these standards are a journey. So while LTE started out with much lower data rates in 2009, by 2016-17, it achieved the goal of 1 gigabits per second over the air interface, and now about 20% or thereabout of handsets support 1 gigabit of throughput. 5G can be looked at in a similar way. The IMT 2020 vision that ITU put out sets the goal for 5G that it will one day, for instance, be able to reach 20 gigabits per second. Not from day one, but eventually we will get there. Similarly, when it comes to the latency, and this was well discussed in the earlier session today, and I will touch upon it a little bit as well, that in the lower right-hand corner, you see the goal is eventually to achieve 1 millisecond of latency to support some very interesting use cases. And then looking at the use cases that are defined as basically three families. The top part of the triangle here talks about the traditional use cases that we're quite familiar with today from LTE, and these are the mobile broadband use cases. They will just be a little bit faster, a little bit more efficient, with a little bit better coverage eventually in 5G. On the lower right-hand side of the triangle, we talk about the massive machine type communication use cases, where there will be significant improvements eventually in particularly the energy efficiency and the cost of the devices, as well as the coverage or the link budgets. The most visionary and I think the most disruptive family of use cases, though, is in the lower left-hand corner, and that's the ultra reliable, low latency communication use cases. And this can really have a disruptive effect on many industries. And here you find use cases that talks about very low latency, ultra reliable communication needed, for instance, for industry automation or intelligent transport and so forth. So this is the vision, the goal, and the use cases. But if we take a little bit of a reality check of where we are today in 2020, I would say that 5G holds a lot of promise, but many of the use cases and things that are thought of is at the risk of being severely overhyped. I've had multiple conversations with colleagues in the industry about this recently, and that made me think about the Gartner hype cycle. If some of you are familiar with it, it's on the right-hand side. And this tries to describe how a technology is initially seeded and then go through different levels of expectations, and it eventually becomes a success and a commercially viable solution. If we look through history of previous standards, and for many of us in the industry, this is not our first rodeo. We've been through 2G and 3G and 4G standardization. A lot of what was envision and what a lot of was developed in those standards. Give example of multimedia broadcast, multicast services, never really materialized commercially, even though it's been part of 3G, 4G, and 5G. You can say the same with SU-MTS and even WiMAX as a 4G standard. Commercially, we will see some solutions work better than others. And one of the most interesting ones, and Luke touched upon from NSR earlier today, that the backhaul use case is one that is well proven today and will continue to evolve and get even better going forward. It works well, it makes money, and satellite backhaul is a fantastic fit for those use cases. If we look at the family of massive machine type communication, it is also partly proven. I mean, 2G, 3G, and LTE today provide very well IoT use cases, and 5G will eventually do it as well. What is interesting here in the satellite context, I believe, is all the innovations that is happening and could happen in S-band and non-terrestrial network access, where you basically develop chipsets that can communicate directly with satellites, and you get the look and feel of a regular cell phone communicating with the satellite, or the same chipset, and then that can be put into IoT devices. Very, very interesting innovation going on there. The ultra low latency communication use case, in fact, it doesn't exist today, but studies are performed and chipsets are on the way, and standalone 5G along with edge computing will enable this use case one day, and this holds a lot of promise. And you know, when standalone 5G along with edge is put into place at an on-premise or a remote mine or something, satellite will fit, because all the low latency, ultra reliable communication will be executed locally, and 5G will provide normal backhaul into the core nodes, data centers, and regular internet. So to give you an update on where we are as an industry in terms of 5G subscription today, Ericsson provides a very good report, Ericsson Mobility Report, that actually came out, an update just yesterday, on where we are on standards. And you can see that 5G is starting to be established a little bit, with about less than 200 million subscribers by the end of this year. And if we look at where the markets where these are going into, if we look at the left-hand side of this graph, you will see that the India, Middle East, Southeast Asia, and Latin America, as well as Sub-Saharan Africa, typical satellite backhaul markets, do not have any 5G penetration today, and by 2025 will have still quite limited penetration, and it will be maybe mostly in urban areas. If we look on the right-hand side of the graph, though, there will be a substantial uptake of 5G in more developed markets, and Northeast Asia, with China leading the way currently in 5G deployments, along with Korea and Japan. Western Europe and North America will be very, very interesting markets for 5G backhaul. So then to look at what solutions are needed and what solutions can support this today, if we look at how Comtech is trying to address this, we already have today 5G ready solutions that is providing 5G backhaul. The point-to-multipoint platform that we offer has been designed from the ground up to support the very demanding requirements from an MNO. These are low latency, low jitter, as well as high throughput, high performance. We work with all major mobile network operators, mobile RAN vendors around the world. So it's tested and qualified with all of these, as well as many of the open RAN community vendors as well. The technology is software defined, both at the hub and remote, and this allows us to provide a service that can adapt and accommodate new technologies as they're being standardized and developed. A simple picture of how it looks and comes together. You have your core network nodes on the left-hand side. If we're talking 5G here today, we'd have the user plane function connecting to a Heights hub that provides a signal over the satellite link out to the remote sites that is in the several hundred megabits range. It's received by remotes, and there are 3 different types out there. And a single remote at the site can transmit traffic back into the network at several hundred megabits per second as well, and includes technology that is important in an MNO use case like header compression, payload compression, and traffic optimization. And I will touch on traffic optimization here a little bit and how it fits into the market and what value it brings. So traffic optimization, TCP acceleration, is something that is available from LTE and onwards. And it enables faster web browsing, smooth video streaming, and provides a fiber-like download quality of experience. And this is really important for many of the use cases that we are addressing. It also helps with isolating packet errors at either end of the link to provide a cleaner link. And it also allows for DNS caching at the remote sites, allowing faster time to content, so the user experience becomes much better. The technology we've implemented really cleverly, so it's a zero-touch provisioning. An MNO does not need to make any changes in their network to apply this technology. It's truly plug and play. And I will show a little video here, and hopefully it will play after I talked about how we optimize 5G standards and the different types of 5G standards that is being rolled out. So what is mostly being rolled out by MNOs currently is the non-standalone version. It acts like an overlay to an LTE network. And eNode Bs and gNode Bs are co-located, and the backhaul is based on S1U. The payload is running on S1U, and this is a protocol we're very familiar with, and we do GTP acceleration on today. So this allows us to see the end user's TCP IP header and do acceleration. Then next generation of 5G will be deployed in a non-standalone mode. And this is when you have a gNode B or a new radio deployed, connecting into something called a user planning function at the core. And the backhaul here is then, again, using a protocol very similar to S1U for payload called N3. Again, this is a protocol that we accelerate and optimize already today. The use case then where we move edge services to the on-premise or remote location is a really interesting one, and allows, for example, for the ultra-reliable low-latency use case to be achieved. And this is when we co-locate UPF with gNode B, and then the traffic basically back from that site is regular IP traffic as it looks and feels on the internet. So it's TCP riding an IP, and that we accelerate and optimize already today. So to demonstrate how this actually looks and feels for an end user, I have this video that I would like to play for you. And if you look on the left-hand side here on the screen in a little while, you'll see a site that is optimized with TCP acceleration, GTP acceleration, and DNS caching. The right-hand side of the screen will be an on-optimized service. So let's see how we can get this video to play. Paul, can you help me get this video to play? All right, so we're having some technical issues getting the video to play. Hopefully it will come in a PowerPoint presentation that will be sent to you later. But the user experience, and I can talk about it, is that on the left-hand side of the screen, the website will be loaded in about 3 seconds. And it looks and feels like you're on a terrestrial connected base station. If it's fiber backhaul or microwave backhaul, you wouldn't be able to tell the difference. The right-hand side is an on-optimized site, and that exact same site takes about 14 to 15 seconds to load. So we have a significant improvement in the quality of experience for the end user. So what is also happening with 5G and what is needed is significantly higher throughput for trunking links. And we see a lot of already today demands for higher throughput with our customers. And the way we address that is with this high trunking, high-speed modem that is the most deployed modem for mobile backhaul trunking in the world. And it's a very, very fast, very quick modem that is able to provide you a gigabit of throughput. It already today supports GEO operation as well as MEO and LEO. And it also comes with all the features and functions that you are familiar with in a telecom environment, like QoS, header and payload compression, and jumbo frame support, of course. And I seem to have lost my presentation here. Can someone on the technical side of this bring it back? Thank you, appreciate it. So we've recently demonstrated this modem with a customer in Africa, providing 1.3 gigabit per second of throughput over a C-band satellite. So if you're listening in from Africa, I can tell you we're certainly ready to deal with your high throughput demands that comes with 5G already today. But what if you want more than a gig of throughput to your cell site? How do we manage that? Well, there's a technology for that as well, and that is called carrier bonding. And here we're actually stealing something from the playbook of LTE Advanced and 5G. If you're coming from the mobile world, you're familiar with carrier aggregation. Carrier aggregation is when you take several different slices of spectrum and you bond it together and make it look and feel like one single link to the end user. We use the same technology with our modems, where we bring together up to 12 different links and we load balance in it. And we then able to multiply the throughput to the end user by creating a layer 2 completely transparent virtual link. Of course, this comes with all the QoS that is necessary. It's also completely transparent to the MNO and the end user, so it's plug and play. And TCP acceleration, GTP acceleration, and caching as well built into the solution here to provide the very best quality of experience possible. This is deployed today in many markets, and one of the largest and we believe the largest trunking network in the world is one that we're providing in Northern Canada for mobile services together with Telesat. And the biggest link we provide up there is 3.8 gigabit per second of throughput, well within the requirements that you will find from 5G today. And in total, we deploy 14 gigabit of capacity in this network. So this hopefully gives you an idea how 5G ready the satellite industry is already today. If you have 5G requirements, the technology exists to provide an excellent end user service. And we're happy to discuss how Comtech can help you deploy these types of solutions. Paul, back to you.
Thank you very much, Richard. Just for the record, Richard is Senior Vice President of Mobile Network Operators, Comtech EF Data, and he does come from a cellular background. I think Ericsson, am I right about that? I seem to remember.
Yeah, 20 years over there.
Okay, well, so, very much a cellular specialist. David, I think we can welcome you to the stage now. Can you hear me?
Yes, I can. Can you hear me okay?
I can indeed. Just let me get your presentation up. I did actually introduce you before.
I heard.
But then I think we had all these technical issues. But let's hope now that we can run through this uninterrupted. And there you are.
All right. Well, thanks very much, Paul, and apologies for the technology issues. I don't know what happened, but I'm on a backup device, and the good news is this definitely had nothing to do with satellite communication. So very much appreciate everyone's participation and particularly the patience. So as you can see from the cover slide, I'm here to talk about the role of satellite in 5G. And I like to think that I'm not going to be hyping satellite, just sticking to the facts. And what I'll do is start with some of the hype that is at least prevalent here in the United States where I'm based. And Paul, could I? Oh, I think I can do it.
Yeah, there you go.
There we go. I got it. All right. So This slide that you see in front of you, this is a slide pretty much typical of what comes out of the mobile network operators here in the US, showing a 5G network. And what you can see that I've highlighted in the middle is from the MNO perspective, 5G is going to be a wonderful, wonderful, transformative technology. And I'm not here to argue whether or not it'll be transformative. Certainly, 5G is going to power a lot of new applications, wonderful advancements, whether it be in medical technology, transportation, office technology. The point that I think I really want to emphasize is that what we're hearing, at least in the United States and perhaps in other parts of the world, is that the wonderful hype, if you will, that's coming out of the mobile network operators needs to be taken, as the saying goes, with a grain of salt, and I would argue a pretty significant grain of salt. So let's look to one of the things that powers 5G and in fact all communications, which is spectrum. I think everyone on the call understands the role of electromagnetic spectrum and the fact that it's like oxygen is to fire. Without spectrum, we don't have the communications. And in the case of 5G, it primarily relies upon and needs spectrum below 6 gigahertz, commonly referred to as sub-6 or low and mid-band spectrum. And similarly, and particularly here in the United States, where there is a shortage of, relative shortage of sub-6 spectrum on millimeter wave spectrum, or otherwise called the high band spectrum. It is important to keep in mind, this is absolutely required in order to power 5G telecommunication services, sub-6 or millimeter. And I'm going to initially focus on some of the issues, and this is physics, with millimeter wave spectrum. And I'm just going to take some of the quotes that are coming from some of the executives in the US mobile network business, the cell phone operators. T-Mobile is one of the premier operators, certainly has a wonderful system here in the United States. But as you can see, their chief technology officer noted that when it comes to millimeter wave spectrum, 5G, quote, will never materially scale beyond small packets of 5G hotspots in dense urban environments. In other words, if you're going to use millimeter wave spectrum, it's an urban application. And similarly, we heard from Verizon CEO that millimeter wave spectrum is not a covered spectrum. Now, here in the United States, there's an organization called the Defense Innovation Board. It's a board of civilian and military experts, an advisory board to the US Department of Defense. And about a year ago, they came out with a study looking at the 5G in the United States. And they made some really important observations, which again go to the physics. When it comes to millimeter wave spectrum, by nature, it does not propagate. It does not travel over long distances. And what that means is you need antennas in fairly close proximity to each other. Having to build many antennas obviously increases the cost of infrastructure. If you're an operator with a balance sheet carrying a lot of debt, that may impair your ability or limit your ability to build out your network of millimeter wave antennas. Another limitation of millimeter wave antennas, and this has been observed in numerous industry circles, is that the waves, they can be blocked. They can be blocked by walls, doors, and in fact the human body. And this, of course, requires more antennas and repeaters, and then that also increases the infrastructure cost. And these observations were again made by this advisory board of civilian and military experts. So just to sum up some of these issues with, in particular, millimeter wave, but I'll come back to the sub-6 spectrum as well. Outside urban areas, it's going to be very expensive to build a 5G network utilizing millimeter wave spectrum because, again, the waves don't propagate, they don't go far distances, so you have to build more antennas, and it obviously builds added cost, particularly outside of urban areas. When you're talking about inside urban areas, of course, you have the many antennas and the cost of building those antennas, but you also have the issues associated with the fact that millimeter waves can be blocked by physical structures, walls, and even by humans. When you're talking about sub-6 spectrum, the issue there is perhaps less severe, but a lot of the promises of 5G that will deliver greatly increased speeds, 10 times improvement of performance over LTE, that's likely not going to be the case utilizing sub-6 spectrum. So if you view communications, whether they be satellite or mobile, it's a pipe. And in the case of the use of 5G by mobile network operators, there are a couple of holes in the pipe, as I just pointed out. So if you look at communication satellites, and as has been pointed out by some of the speakers that preceded me, there are some unique advantages that satellite brings. I think a lot of people in this webinar are familiar with these advantages, and top of most is the fact that the coverage is ubiquitous, that the satellites, they see very broad geographic regions. And so a lot of the cost of seeing a region is up in the sky, and it's a one-time cost. Satellites, of course, are very, very reliable, 99.9% reliability. And when you're talking about natural disasters, which often disrupt mobile communications by bringing down towers, by cutting down or eliminating power, at least temporarily, satellites don't have that disadvantage because the infrastructure is largely up in space and not affected by the Earth-based disaster. Satellites can deliver, the higher powered ones can deliver broadband services with speeds greater than 100 megabits per second. So I think I saw in today's news, Inmarsat, a satellite operator, just noted that it was delivering speeds in excess of 100 megabits per second to aircraft. I think the other main advantage that I want to highlight about satellite is that it can be targeted to particular regions via spot beam, software-defined technology. And so it really has the main strength of being always there and always on. And that, I think, means that satellite, as you've heard from the other speakers and future speakers, will play an important role in the 5G network. To spend a couple of minutes on low Earth orbiting satellites, LEO satellites, and certainly within the satellite industry, they've received some attention of late, some media attention, both good news and bad news. I'll take the bad news. Two of the leading LEO operators, OneWeb and LeoSat, both in the midst of deploying their networks. LeoSat at the end of last year announced that they were going to cease operations due to a lack of capital. OneWeb shortly, I would say in late March, announced that they had filed for a restructuring in Chapter 11 under the U.S. bankruptcy laws. And OneWeb attributed at least part of their issue to the COVID-19 pandemic. So it remains to be seen whether OneWeb or LeoSat, whether they ever are able to deploy a 5G network or their LEO network, which obviously would be utilized for 5G services. That leaves still within the LEO system the leading operators, planned operators, SpaceX, Elon Musk's company, which has launched several hundred low Earth orbiting satellites. Amazon, their Project Kuiper, and then also Telesat, which is an operator of geostationary satellites based in Ottawa. And they also have plans to launch their LEO network. The advantages of LEO, I think you've heard before: low latency. A number of applications are sensitive to latency, which is greater with geostationary satellites as compared to low Earth orbiting satellites. But LEOs also have the advantage of broad coverage. LEOs will deploy in the very far northern and southern latitudes. And in fact, SpaceX had recently announced that they will start beta testing of commercial services in the next few months. So in short, LEOs will provide 5G services. It's too early to tell which LEO system, SpaceX, Amazon, Telesat, or perhaps another one, will be the first to market. But certainly LEOs, in addition to geostationary satellites, will play a significant role in the future 5G network. So to sum up, that's the slide I showed at the beginning that is promoted by the mobile network operators that appears to indicate that the future 5G network will be exclusively powered by the mobile network operators, where the reality is that 5G is going to be enabled by a complementary set of networks. It will certainly be significantly terrestrial based, but it also will be significantly satellite based. These services largely complementary, but sometimes I suspect they'll be competitive, and then the attributes of satellite, its ubiquitous coverage, its resiliency, its reliability, will at sometimes tip the scales, and you'll see 5G networks, and I would say for IoT in particular, there are significant advantages due to the reliability and cost effectiveness of utilizing satellite networks for the Internet of Things. So with that, I thank everyone for their attention, and again, apologies for the technology issues earlier on. And Paul, back to you, and happy to answer any questions that may come later. Thank you.
And thank you, David. Right, I'll put you on mute. The golden rule with webinars is if you're not speaking, put yourself on mute, because it causes all kinds of interference. Now, can I ask Luc Perard to join us, please, on stage? Luc, can you hear us?
Yes, can you hear me?
I can. We can't see you, but never mind. At least we got your voice. That's the important thing. Just bear with me. I'm just going to put your slides up. Second. Here we are. Now, like I say, because there are so many different industries sitting in listening to this, it's necessary to introduce all of the speakers. A general SATCOMS event, they all tend to know each other, so you can kind of skip that part. But when there is a lot of out of industry activity going on, it does become necessary to introduce people. So just very quickly, Luc is highly successful in designing and executing go-to-market and sales strategies in the digital and Internet of Things industries. In addition to his current role with Eutelsat, Luc's experience includes spells at Cisco Systems, Vodafone, Accenture, and ThingWorks. His current position is Senior Vice President, IoT Business, Connectivity Business Line at Eutelsat. So, over to you, Luc.
Yes, thank you, Paul, and good afternoon, everyone. So, yes, I'm Luc Perard. I'm Senior Vice President of IoT Business at Eutelsat. And today, I will specifically discuss about IoT, a fast-growing area of the connectivity business, which has typically been dominated by terrestrial technologies from 0 to 5G. In the next 10 minutes or so, you will hopefully realize that satellite is about to play a much bigger role in IoT connectivity, while remaining complementary and even nicely integrated with existing terrestrial IoT networks. First, for those of you who wouldn't know who Eutelsat is, here are a few data points about us. We are one of the world's leaders in the satellite industry, operating a global fleet of geostationary satellites. We are about 1,000 people, and our mission is to deliver all over the planet highly reliable communication services, such as video, broadcasting, and connectivity to a wide range of enterprise service providers and government customers. We are continuously investing in new markets and technologies, and the Internet of Things is one of the company's top 3 priorities for growth. So IoT is an exciting but complex business. what everyone would agree upon is that IoT has now become critical for any organizations to operate, enabling them to save costs, but also to increase their revenue and even generate new revenue streams. To realize the benefits of IoT, the very first step is to connect remote assets in order to extract useful information from them, like sensor data, or to send them commands or content, like firmware updates. But even in 2020, moving data between a remote asset and a remote server is not necessarily straightforward nor easy. For instance, there are many assets worth connecting which are located in areas where terrestrial communication networks are not present or simply not reliable. On the other hand, as you can see on the right-hand side of the slide, satellite presents unique advantages highly applicable to IoT and to connecting remote assets. First, satellite truly works everywhere as long as you can see the sky. Also, satellite communication services are typically very reliable, much more than most communication services which rely on terrestrial infrastructure. However, up until today, satellite has been barely used to connect remote assets. We estimate that 0.3% of all connected assets in 2019 made use of satellite communications to exchange data. This represents less than 3 million assets out of a total of 1 billion connected assets, which relied on satellite connectivity. Why is that? Well, very simple. All existing satellite communication services have not been designed for the unique requirements of asset connectivity. Instead, they have been built to meet the specific challenges of other segments like broadband or backhaul or maritime and even voice communications. Eutelsat has identified a big market opportunity here, delivering satellite communication services purposely designed and optimized just for the unique requirements of asset connectivity. We aim to make satellite IoT connectivity truly simple and inexpensive. So we are thus proposing an extensive portfolio of satellite IoT offerings that address the various connectivity needs of assets. Traditional VSAT networks on the left-hand side here work great for assets needing to transfer large volume of data at high speed, like for instance, video surveillance camera. But the majority of connected assets don't need megabit per second speeds, nor do they send or receive gigabytes of data per month. For them, we have created IoT First and IoT Move. They are highly innovative managed connectivity services bundled with satellite terminals. Together, they enable enterprises to connect over IP fixed and mobile assets at a fraction of the cost of existing VSAT and mobile satellite services. And last but not least, ELO on the right side of the slide here, which stands for Eutelsat LEO for Objects. Thanks to a LEO constellation of nano satellites, ELO aims to provide a unique network infrastructure seamlessly integrated with the terrestrial LPWA networks, such as Sigfox LoRa, but also their 5G counterparts, NB-IoT and LTE-M, extending their coverage to anywhere on the planet while maintaining their distinctive features: low power, so that objects can run years on a battery, and low priced, with service subscription in the range of 10 euro per year per object. So today I wanted to provide you with a very quick overview of IoT First, our new and disruptive satellite IoT offering, which we launched at the end of last year. I will also briefly talk about two IoT use cases which are ideally served by satellite technologies and IoT First. So, in a nutshell, IoT First is VSAT made simple and inexpensive, just for IoT. It is an off-the-shelf offering which bundles compact satellite terminals with a subscription to a managed connectivity service. You buy the terminals, which are in stock today. You install and connect them to your assets in less than 30 minutes. And here they are online. Subscribe to a data plan that meets their connectivity needs. IoT First is fully operational today across the Americas, Europe, Middle East, and Africa. It leverages Ku-band and enables enterprises to reliably and securely connect their fixed assets, no matter where they are located. Last but not least, both the IoT First terminals and the monthly recurring service charge cost 3 to 10 times less than alternative satellite solutions, which puts IoT First in the price range of cellular /4 or 5G connectivity. So as promised, two industries which are sweet spots for IoT First. We start with banks and retailers who operate ATMs and point of sales terminals. These are assets typically spread out everywhere across the country, in both urban and rural areas. To carry out their transactions, those machines need to exchange only small amount of data with remote authentication servers. If they cannot reach those servers, the transactions cannot be completed, which means lost revenue for the bank or retailer, as well as a negative experience for the customers. IoT First is ideal to connect ATMs and point of sales terminals. First and foremost, it works literally everywhere, as long as you can install the compact IoT First terminal outdoors facing the sky. Second, it is truly inexpensive, finally making satellite IoT connectivity as affordable as cellular IoT connectivity. Last, satellite offers inherently secure communications, which are hard to jam or intercept. Note that IoT First proposes advanced security and networking features like IPsec encryption and VRF VLAN in order to meet the stringent requirements of banks and retailers. With IoT First, banks and retailers can now connect all their ATMs and POS and point of sales terminals and serve their customers in more places than ever before. We also see a very high interest for IoT First among tower companies. Their assets, in their case telecom or TV or radio towers, are deployed everywhere, sometimes throughout multiple countries and even continents. They need to connect their towers to constantly monitor them to ensure that they operate at the level of service expected by their clients. And with their towers now connected, they can also track and optimize the cost of operating them by measuring their power consumption, detecting fuel theft, etc. Tower companies are considering IoT First as their preferred connectivity option for their tower monitoring solutions because it guarantees them to have an independent, highly reliable, and secure connectivity into all their assets located throughout one or many countries or continents. Moreover, IoT First presents a very low total cost of ownership for tower companies. The cost of terminals and service subscriptions are much lower than traditional VSAT equipment and services. And the rapid installation of IoT First kits in less than 30 minutes means that tower companies save on time and resources to get their towers under control. And yeah, this is now the end of this short presentation. You can continue exploring the portfolio of IoT services and check our blog, which contains a number of posts and insights specifically about IoT and industry, which would benefit most from satellite IoT. Thank you for your attention. Back to you, Paul.
Thank you, Luc. Very interesting. It was referenced in your slides, the idea of connected cattle, which I think is one of the more interesting IoT applications. I was really hoping you'd talk about it, but never mind. We'll go into that perhaps at another conference. Now, our final panelist is Munira Jafar, who is Director of Spectrum and Standards at EchoStar. And Munira's background is in technology management, business and strategy with extensive experience in wireless telecommunications, spectrum and public safety broadband. Prior to EchoStar, she held a number of high-profile positions with Lockheed Martin and the First Responder Network Authority. So bear with me. I'm just going to bring Munira's slides to the stage.
Thank you, Paul. Just
My pleasure.
Okay.
Hello, everyone. I am Munira Jafar with EchoStar Corporation. We are one of the leading providers of satellite communications with services in the Americas and Europe. Thank you for this opportunity, and I am delighted to share some information and views on the topic integrated satellite with NTN and 5G infrastructure. For the next 10 minutes or so, I'm going to cover briefly these areas. Satellite as a key element of 5G networks, integration with 5G infrastructure, non-terrestrial networks or NTN, high-level view on integration of NTN with 5G, the progress and the status of NTN in 3GPP, and the opportunities. First, satellite is a key element of 5G networks. The substantial added value of satellite to the access technology mix for 5G is becoming increasingly clear, especially for mission-critical and other applications where coverage is crucial. Key characteristics of satellites that include wide area coverage, reliability, and resiliency. This will all be critical to the success of 5G networks. In other words, satellite will play a critical role in bringing services to users quickly, regardless of geographic locations or terrestrial infrastructure availability. Let's look at satellite integration with 5G infrastructure. 5G networks will create a new generation of connectivity. It offers faster speeds and more reliable connections. It promotes a flexible and adaptable technology framework, and is fully capable of supporting multiple access technologies that can best respond to the expectations and demands of the market. The advent of 5G is already supercharging the growth of broadband and machine-type communications, creating further demand for the global infrastructure to carry unimaginable amounts of data. So because of the flexibility and its adaptability to multiple access technologies, 5G offers a unique opportunity for the satellite industry to fully establish its place in the global communication ecosystem. Satellite is a part of non-terrestrial networks or NTN. The satellite industry, including EchoStar and Hughes, have been engaging proactively with mobile and other key stakeholders at 3GPP and other forums to ensure that satellite technologies are fully integrated into the emerging 5G networks, and also to support the goal of bringing 5G communications to everyone, everywhere. The main objective is to have non-terrestrial networks included in the 3GPP 5G specifications and standards. This will enable seamless integration with the 5G system, including at the radio access network level or RAN. Also important is to leverage 5G technologies to benefit from economies of scale in the 5G global market. Many stakeholders view that full integration will open new market opportunities for satellite solutions and bring 5G users worldwide all the benefits of seamless global communications. I hope you find this slide interesting. The diagram illustrates a high-level view of satellite or NTN integration with 5G infrastructure. It shows all the constellations, GEO, MEO, and LEO. So each constellation has its own good characteristics and challenges, of which most of them had been studied and evaluated with regards to adaptability to 5G new radios. The diagram also shows that satellites are connected to the same 5G core network as the terrestrials. So this helps with seamless integration with terrestrial networks. And depending on the constellations, many types of services can be delivered directly to end users. For example, LEO being on the lower altitude can serve smartphones and many more. And from MEO and GEO, it should provide direct access to IoT applications to billions of devices for farms, agriculture, manufacturing, and many more. Also important are services to ships and airplanes. So all of this will be very exciting. I'm happy to share the progress on NTN in becoming part of the 3GPP 5G standards. First, the normative phase of the standardization of NTN in 3GPP commenced in January of this year as part of Release 17. This is good news. The two studies that were completed to support this, solutions for NR to support NTN in Release 16, that was completed in December 2019, and the study for architecture aspect for using satellite access in 5G. Second, and equally important, a study phase on narrowband IoT and machine-type communication to support non-terrestrial networks. It's also being undertaken in Release 17. So this is great. The consensus appears that the rollout of satellite-friendly network and user equipment based on the upcoming 3GPP NTN-NR standard is expected somewhere around 2023 or slightly after that. So I have shared with you at a high level on non-terrestrial networks integration with 5G and its progress to date. I would like to end my presentation highlighting the opportunities for NTN New Radio and NTN IoT. As we know, many parts of the world still lack access to connectivity. Any country can benefit from the use of satellite. So there are tremendous opportunities for non-terrestrial networks to broaden 5G service delivery and connectivity, especially to unserved and underserved areas, extending and complementing cellular networks. There will be great opportunities in providing access to a variety of broadband and IoT applications, potentially billions of devices, for vertical and consumer markets, public safety, and many more. Given the global COVID-19 pandemic, satellite offers an even more compelling case for the essential role of satellite within 5G. For example, expand global collaboration among health communities, extend access to telemedicine, accelerate economic activity, and facilitate social distancing. With that, I end my presentation. I'm happy to answer questions. Thank you very much.
And thank you, Munira. Now, can I ask everybody to come back on stage? And while you're doing that, I've got a question that David is probably the best person to put this to. This actually comes from an MNO with licenses to operate in most sub-Saharan countries. And ironically, they're probably in a better position to answer this question than any of us. But the question is, will we see a time and perhaps a trend whereby MNOs will be acquiring satellite operators? Would there be antitrust issues, do you think, there?
There we go. Okay.
Oh, yeah, okay, we got you.
Good question. The question about whether there are antitrust considerations, that will obviously vary from regulator to regulator. I'm more familiar with the U.S. antitrust authorities, but my belief is that no, generally there are not antitrust considerations as long as there is robust competition in communications in general. I do think the fact that satellite is complementary for the most part and somewhat competitive in discrete areas to the mobile network operators, I do think it's a natural potential acquisition. I'm not aware of anything imminent, and if I were, I probably couldn't say anything. But I do think it's a possibility for satellites companies to possibly integrate with mobile operators.
Mm-hmm. Okay, very good.
Paul, I think the stage is full that I cannot open my webcam.
We can hear you, so that's good enough. Should accommodate 6 people, and there are 6 of us here. Luke, are you there? Richard? Okay, Anthony, if you could.
I'm here.
Okay,
Yes,
very good.
I am.
Okay, fantastic. All right, good. We're all here. As long as you can hear us, I think that's good enough.
Yeah. And I can add to something that David was talking about.
Yeah, please do. Carry on. In the meantime, I'm going to mute everybody until you want to speak. So sorry about this, but it does prevent a lot of technical problems. So please carry on, Richard.
Right. So there is precedence of telcos and MNOs taking an interest in satellite systems. For instance, SoftBank is or was an investor in new satellite constellation, and so has Bharti been, and Vodafone and a few others. So there is already interest from the telecommunication community to invest in satellite technology, and they've been doing so already.
Okay, interesting. Okay. Is anybody else got anything to add to that point? No? Okay, here's I think somebody referenced Leo. I think it was David actually, LeoSat and OneWeb earlier. How would the business model for future large LEO constellations be different from past attempts? Anybody?
So let me, David here. Let me start the conversation. I think the big challenge, and for those who've been following the industry for more than 20 years, like myself, you can go back to the 90s, where Teledesic, I think, is an off-sided example of internet in the sky. And LEOs very much are focused on providing broadband coverage to underserved areas, with the advantages that have been illuminated by the various speakers, such as for the Internet of Things and 5G services as well. I think the main issue really is going to be with the terrestrial-based technology, the antennas. And what will be a successful business for LEOs is to develop low-cost antennas that can be widely deployed rather readily. We're going to see, I know that the folks at SpaceX with their LEO system have promoted an antenna that we'll hopefully soon see that looks, I think it's been described by Elon Musk as a UFO on a stick. We'll see that if he's able to deliver the very simple technology which he's spoken about, which is plug it in and point it at the sky. That's going to be the main differentiator, I think, in the success of LEOs. Some LEO systems, and we heard from Luke at Eutelsat, are very much focused on the corporate or IoT sector, and I think that's a smart bet. We've seen from Telesat that is their plan as well. Whereas it appears that the SpaceX vision is more consumer-based, but again, it's early days. But I do think low-cost antennas is going to be the differentiator.
Yeah. I've unmuted everybody because it doesn't seem to be causing any problems. So please speak up. Anybody want to expand on that? Okay, right. This. First of all, let me say that was a question from a ground station solutions architect at Amazon Web Services. So I forgot to mention that. But this is a question from the product manager for satellite networks at British Telecom. Each VSAT platform has to be proprietary until now. Will 5G bring true inter-vendor operability? And we've been talking about this for some time, but please take that up. Anyone?
Yeah, this is Banu. I don't necessarily say that at this time it's all proprietary, because the VSATs really provide a Ethernet interface typically to equipment at the cell site. So in terms of perhaps optimizing the user experience and spectrum, there could be tighter integration that through standardization would be good for 5G, and mixing and matching different equipment providers.
Okay, while you're here, Banu, a question came in for you. Are satellite service providers ready for 5G today? If not, what are they doing to get ready?
Yeah, I would say satellite networks are mostly ready for providing backhaul connectivity for 5G. Given the current deployments for 5G are with non-standalone configuration, most of the satellite networks used for backhaul already have, the key ingredients for making this happen. As many of the required capabilities are very similar to what is currently deployed for 4G LTE network. For example, these include, broadband support with over 100 megabits of traffic delivered to the site. One of the speakers spoke about the acceleration of traffic. That is a key part of it. Providing proper QoS treatment for various applications. And of course, as I spoke, SD-WAN for intelligent routing between terrestrial and satellite wide area networks, that exists. A lot of work, of course, is also going on SDN and NFV for significant performance, as well as network scalability. In addition to all of this, satellite ground networks are also evolving to work with next generation flexible satellites, to be able to provide dynamically bandwidth and capacity where it's needed. And this is very important for 5G networks. Also, satellite networks and service providers are running many interoperability tests today, with 5G new radio and integrating subsystems like mobile edge computing and caching. So yeah, I think there's a lot and they're ready.
Anyone want to add to that? Okay, this is an interesting question. It's come from Telefonica in Chile. Actually, a satellite planning engineer, as I say, Telefonica in Santiago. Is satellite going to be part of the 5G deployments in big cities? We always think about satellite as being the rural solution, but nobody?
Well, let me start. I think the answer is absolutely yes. Certainly, satellite has distinct advantages in rural or underserved areas, but there are urban areas that are relatively underserved. I also think the reliability of satellites will attract a number of customers who are sensitive to service disruption, latency issues. Concerns about latency. I think LEOs and MEOs certainly will attract customers in the urban environment. Businesses, again, that are seeking reliable communication links will look to satellite. Will it be an exclusive provider in urban areas? No, I don't think so. But I think for a number of potential customer sectors, satellite in an urban context is a very viable and in many cases necessary means of communication. So yes, it will be part of the 5G network in urban areas.
Okay, and I think that has huge ramifications, because you're talking about traffic control. I mean, there's all kinds of applications. If it does, if it is a workable solution for urban areas, that really does raise the bar.
Yeah, I'd like to comment on that. I agree as well. Satellite has a role to play, both rural, suburban, and urban. And one of the key points to the advantage of satellite is, of course, the ubiquity and the reliability. And since we're talking about Santiago, Chile, which is prone to earthquakes, for instance, and we have fiber cuts and misaligned microwave towers are quite frequently affected by earthquakes. So their satellite can form backup connectivity and increase the availability of the cell site. This is something that we deploy in other markets around the world that are prone to earthquake, for instance. And of course, you have all the public safety requirements and the mobility requirements, where you can bring your network and connectivity with you and set it up on a moment's instance, augmenting and improving your network reach. That's also a use case for satellite, wherever you are, rural or in the city.
Anybody else?
Yeah, as I spoke earlier, clearly, resiliency, traffic offloading, I mean, that is very important, especially busy hours, be able to intelligently route traffic as needed away from the terrestrial networks. And of course, smart cities and IoT applications.
Okay. This is from SpaceX. One of the business development directors there. Does 5G over satellite make sense? Aren't the key 5G benefits lost over satellite? Which is a good, challenging question, and I'm sure.
This is.
Sorry, carry on, Munira, please.
Yeah, can you hear me okay?
Yes, very well, thank you.
Yeah, I think as I described earlier in my presentations right now, the work that we're doing in 3GPP is towards enabling satellite to be part of the 5G standard. It means a full integration of 5G ecosystems. So, but as we're aware, there's still challenges in, especially the different constellation. I mean, many have spoken about LEO being maybe the least challenge, but even LEO has its own challenges as well. So really the last year and a half that we've been studying all these challenges, as I mentioned, at least the fundamental one being addressed and has been completed and been accepted by the 3GPP communities. And that's one of the reasons that we're moving into the normative phase, and hopefully the standards will be in place by the end of really 17, by the end of year 2021, that would enable not just the infrastructure, but also the chipset maker be able to incorporate the satellite features in the system. But as the 5G evolve, and so is NTN and 5G integration, there are many fixes that needs to be done in future releases 18, 19, and so on. So the answer is yes, it should be, but I think probably depends on the services as well, whether it is smartphone, broadband to smartphone, or maybe in some rural areas or extreme rural areas where there's not even 2G or 3G there. I mean, you could even offer satellite services direct to end users for a 2G or 3G performance level.
Okay. Anybody else?
I would just say that 5G and LEO networks are natural partners. What the LEO brings is the coverage, the ubiquitous coverage, and certainly that's amplified in the far northern and far southern latitudes. It also is very attractive for applications that are sensitive to latency, because signal obviously will have to travel far less distance to a satellite operating in low Earth orbit compared to geostationary or even middle Earth orbit. Mm-hmm. So I do think there is a natural role for LEO systems to play in the 5G network. Absolutely.
Okay, now here's a pretty general question, but just the same, I'd be interested to hear what you say in response. Which vertical industries would be the best 5G partners to satellite? Where do you think the main applications will be?
I think short term is if we are to follow the money, it's still traditional backhaul that will be the biggest market Over time, other use cases will develop. As Munera is explaining, the IoT use cases will be generating also business opportunities. But for now, the focus is on backhaul.
Okay. Anybody else?
I think any application that require coverage, especially in areas where terrestrial is probably not available there, that probably be the most, the second one, or maybe emerging for satellite solutions to look at. And also it depends on, if the service is available there, and then there will be growth market there as well. So it will keep on evolving.
Okay, good. When will it be possible to use our 5G phones through satellite?
What was the question again?
When will it be possible to use our 5G phones through satellite? And this is from one of the senior systems engineers at Thales.
Oh, okay. So Thales should know better. Yeah. But anyway, to answer that question, I think I mentioned earlier, this is just still, I would say, projection or speculation. The Release 17 should be completed by the end of year 2021. So it may be some more functionality or features that need to be added to the specification, could go into Release 18 as well. So realistically, I think a satellite-friendly network with 5G NR radio or NB-IoT technologies probably will be available somewhere year 2023. Perhaps a network be deployed in. Then only you can say, yeah, satellite 5G phone can work through satellite, and we don't know whether that's going to be the first one are going to be LEO or MEO or GEO.
Okay, good. One last question I think we can take. How will the business model for future large LEO constellations be different from past attempts?
I think that's similar to the earlier question, which really you look at some LEO systems which are focused on the corporate network, and I think certainly Eutelsat and Telesat are primarily looking at that market. I think that's a differentiator from earlier LEO systems. Other LEO systems, such as the SpaceX system and OneWeb, which of course now we have a question mark next to, we're more focused on consumer, where I do think the ability to deploy a low-cost antenna that can be readily installed and maintained, that's going to be a key differentiator compared to earlier systems. So that's my view.
Okay, what is the situation with flat panel antennas?
Well, there's a lot of talk. There are some promising projects. They work. Clearly, the issue, if you're going to be talking about consumer applications, is cost. Can you get the cost down to what you see, for example, with direct television antennas?
Okay. Anybody else on that question? Okay, good. Well, it's been a long afternoon. Thank you very much, panelists, for answering these really difficult questions. I know some of them have been really quite challenging, but we picked them out, in accordance. We're looking for questions that you may not have heard before, and hopefully we've achieved that to some degree. But thanks very much for your presentations. They've been absolutely excellent, and look forward to working with you again. We'll be doing a number of these. As I say, we're looking to do 10 of these a year. In a program called the Connected World Series. So, baseball fans, I'm sure you'll appreciate that connection. But it's been great working with you, and thank you very much. So I'm just going to make the concluding remarks. And once again, thanks very much to all of you. Stay safe.
Thank you. You too.
Bye.
Thank you.
Thank you.
Oh, my pleasure.
Thank you.
Bye-bye.
Okay, well, thank you all for attending. There has been a lot of you, and for those of you that made it through to the end, you know, I admire your stamina. It's been a very, very interesting discussion. There have been some great presentations. Like I say, keep monitoring the website. All of you will receive information anyway, because I'm sure you're on our circular. But we are planning some very, very interesting programs just like this, with some very, very erudite speakers going forward. You'll all hear about them. In the meantime, take note that these proceedings, this particular program, has been recorded. You can watch it on demand anytime you like. You're more than welcome to contact me if there are any other questions to put to the speakers. You can screen save this this card and send me an email, and I will ensure that whoever it's directed to will receive it. Because I'm very interested in actually keeping the dialogue going, you know, past the time frames that we're limited to with the actual program itself. So I'm going to say goodbye to you all. I'm going to stay safe and well, and I look forward to all of you attending the next one, which is actually on July the 8th, and it's on the subject of connected transport, which is something else that I've been interested in for some time, and I think you know, is with the kind of innovation that is going on in the transport sector at the moment, I think is going to be a very interesting program. So with that, I'm going to end the webinar and look forward to seeing you all at the next one. Bye now.